All right, so we're going to go through a basic understanding of what acceleration is. There are a number of different equations that we can use for acceleration, but this video is just going to go through just the fundamental understanding of what acceleration is, and then later on we'll go through some more of those mathematical ways that we can actually solve for acceleration. So acceleration, the best way that I can think about it is it tells you how much your velocity changes each time interval. Okay? It's very similar to when we had velocity. Velocity told us how much our position changes, right? It's a change in position each time interval. Whereas acceleration now has a very similar format as in terms of velocity, but is now a change in velocity over time. If we write that out, that gives us final velocity minus initial velocity divided by the time it takes to go from whatever the final to the initial was. That is our basic understanding of how to calculate acceleration. Acceleration is typically measured in physics in meters per second squared. What that is I think better understood when we break that apart, right? So in terms of velocity, a change in velocity is going to be measured in meters per second, and a time is going to be measured in seconds. So a meter per second squared is meter per second per second. How I like to think about this are in a little bit different of units, and those units are miles per hour per second. So if we can think about how we are moving miles per hour, right, in a car, how much does our velocity, our miles per hour, change each second? Here's an example, right? Let's say something has an acceleration equal to 5 miles per hour per second. What is that object going to look like as time goes from time 1 to 2 to 3, right, as the object is moving? Well, initially we're going to say it's at rest. After 1 second, now the ball is moving, and it has a velocity. What is that velocity? Well, if its acceleration is 5 miles per hour per second, after 1 second, this would be going at 5 miles per hour. Remember, acceleration tells us how much your velocity changes each time interval. After 2 seconds, the acceleration is telling us that it's going to be going faster. Its velocity is changing by 5 miles per hour. So now the velocity would be 10. After 3 seconds, if we're still accelerating, the ball should be going faster, and the velocity would be 15. We could keep going. After 4 seconds, the velocity would be 20. Notice that the velocity changes each time by positive 5. That's the acceleration. It tells us what is our velocity doing each second. In this case, because our acceleration was a positive 5, our velocity was changing by positive 5 each instant. You could also have a situation where our object is here at time equals 0. It's already moving with a velocity equal to negative 32. We're going to maintain this same acceleration of a positive 5. After 1 second, our object is here. It's still moving that direction, but our velocity had to have changed from here to here. Our velocity had to have changed by positive 5. So what that tells me is that my new velocity is negative 27. The ball has slowed down, or the object has slowed down. Do another second. Our velocity still has to change by positive 5. So now our velocity is negative 22. We have slowed down. Third second, now our velocity is negative 17. Again, it changed by positive 5. So both circumstances have an acceleration of positive 5. The velocity changes by a value of positive 5 each second. In this case, we're speeding up. In this case, we're slowing down. Let's look at an example now of when we have a negative acceleration. So we're going to work through 2 more examples. Both of them are going to deal with an acceleration of negative 7 miles per hour. The first one, at time 0, we're going to have an object moving to the left in the negative direction with a velocity of negative 3 miles per hour. So let's look at what their velocity would look like each second as their motion is taking place. After 1 second, our ball would be moving a little faster. They would have a velocity of negative 10 miles per hour. Notice our velocity changes by negative 7. At 2 seconds, now our velocity is negative 17. Again, our velocity changed by negative 7 miles per hour. After 3 seconds, velocity is negative 24. Again, our velocity changes by negative 7 miles per hour. That's what the acceleration tells me. The velocity has to change by a value of negative 7. Our last example, let's say we start with the ball moving in the positive direction at 40 miles per hour at time 0. Can you pause the video and go ahead and fill in what the next 4 seconds would look like in terms of the velocity of the ball each second? Looking at this, what we see is, again, each moment we have to change our velocity by negative 7. So we go from 40 to 33 to 26 to 19 and finally to 12. Each moment our velocity is changing by 7 miles per hour each second that's happening. Now, what you'll see is, again, a negative acceleration can cause something to 1, speed up, or 2, slow down. So be careful, because negative or positive acceleration doesn't tell you speeding up or slowing down. Let's see what the rule of thumb is for acceleration as to what the negative or positive actually tells me. But before we do that, I want to just point out, and what you'll see is our distancing is not constant. We're not moving at a constant velocity. In this case, we see from time 0 to 1, and then 1 to 2, and 2 to 3, our spacing is getting farther apart. Because we are speeding up, we are covering more distance each second. Oppositely, for this one, our spacing from 0 to 1 to 1 to 2, 3 to 4, and 4, so on, is getting shorter. And that's because we're slowing down, meaning we're going to cover less distance each time interval that we would be. Also, with this is the velocity at this second. At that moment in time, it is going 33 miles per hour. At this moment, it's going 40. The entire time, it is slowing down. Right, so if I wanted to find like the velocity average for this moment, well, I would 40 here and 33 here. The average velocity would be just the average of those two values. 44 plus 33 is 73. Divide that by 2 and you get 36.5 miles per hour. Some important ideas with acceleration. One, it is a vector, which means it has both a magnitude and a direction. The magnitude tells us how much you're speeding up or slowing down by. The direction tells me which way is our acceleration pointing. Now, that can be very helpful, because to tell if something is speeding up or slowing down, we have to look at how the acceleration compares to our velocity. If the velocity and the acceleration have the same direction, then something is going to speed up. Meaning, if we have a velocity is positive and acceleration is positive, that means speeding up. Or, if we have a negative velocity and a negative acceleration, that also means speeding up. If velocity and acceleration have the opposite signs, the object slows down. So when we have a positive velocity and a negative acceleration, or a negative velocity and a positive acceleration, those are both going to be instances where an object is going to slow down.